Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to review some graphs involving shifts, reflections, etc. We're going to start off with the first two involving either a vertical shift or a horizontal shift. We want to graph f of x equals x cubed plus 2, and we know that the graph of x cubed, and I'm going to graph this in red for now, goes through these points 0, 0, 1, 1, 2, 8, -1, -1, and -2, -8. This plus 2 is a vertical shift. And so basically we want to take the original graph of x squared, pick it up off the paper, move it up 2 units, and redraw it there. So switching back to black, 0, 0, that original point moves up 2 units. And so does the point at 1, 1, and so does the point at 2, 8. -1 goes up to -1, +1, and finally -2, -8 goes up to -2, -6. Okay. So you can kind of see there with both sets of dots on the graph how the black graph is basically 2 units higher than the red one was. And it's going to look something like this. Oops. Now it does ask for the largest open intervals of the domain over which the function is increasing or decreasing. And so we measure increasing or decreasing from left to right. And as we look from left to right, this function is always increasing. So that would be -infinity to infinity. Decreasing, it doesn't decrease at all. Right. Let's take a look at the second one, which is going to be similar to this, except now that plus 2 is inside of the parentheses, right? In the last one, we looked at x squared, x cubed plus 2, but now it's x plus 2 quantity cubed. So that is a vertical shift of 2 to the left. Let me put the original x cubed points back on the graph, 0, 0, 1, 1, 2, 8, -1, -1, -2, -8. And now we're going to shift this 2 to the left. And the reason for that, the horizontal shift is always inside the function. It's inside the part that's being cubed here. And what we really want to think of this is not as x plus 2, it's really x minus -2. And that number that you're subtracting, h, tells you the number of units for your horizontal shift. So here it's -2, so that's going to be 2 units to the left. I'm going to switch back to black ink, and I'm going to move each point 2 to the left. Something like that. Now, just like the last graph, and by the way, you can see, right? You can see with the red dot still there that we're moving 2 units to the left. In terms of increasing or decreasing, this is just like the last one. This one only goes up to the right. So the interval where it's increasing is the set of all real numbers, and as far as decreasing, it doesn't. All right, one last one. Sketch the graph of f of x equals -3 x plus 4 all raised to the 4th power plus 1. And so this time we want to start with the idea of what the x to the 4th power graph looks like. But then we're going to shift it both horizontally and vertically. We're going to reflect it over the horizontal axis, and we're going to stretch it by a factor of 3 as well. So there's a lot going on here. I'm going to start with what the graph of x to the 4th looks like. And I'll do that in red again. I know that it goes through 0, 0, 1, 1, and -1, 1. And then it goes up really sharply from there. So the 1 is the vertical shift of 1 unit. So that means everything's going to move up 1. X plus 4 is the same as x minus negative 4, like we saw in that last example. This is a horizontal shift of 4 units, and this is going to be to the left, right? Negative 4. The negative sign we're going to reflect it over the horizontal axis. And we can basically reflect it once we've shifted it. The turning point, like the vertex of the parabola, that stays the same, and then we open it downward from there instead. Finally, the 3 is a vertical stretch. And so the points are going to drop, in this case, 3 times faster than they did before. All right, so the first thing that I want to find really is this point HK. That's where the point that was at the origin is going to end up. So I'm going to shift it 4 units to the left and up 1. So from the origin, I count 4 to the left and up 1. That would be about here. Then I know it's going to open downward, but I need to take that 3 into account. So in the original graph, it was over 1, up 1. In this new graph, when we go over 1, it's going to go down 3 units. So from that point, I can count down 3 units, 1, 2, 3, 1, 2, 3. And then I could go even further. Something else that you could do if you don't like counting them that way is, okay, I could plug in a point on either side of negative 4 to get those points. So let me show you what that would look like. To the left of negative 4 is negative 5. And to the right of negative 4 is negative 3. And I'll do both of those. So this would be negative 3 times negative 5 plus 4 to the 4th power plus 1, which is negative 3 times negative 1 to the 4th power plus 1, which is negative 3 times 1 plus 1, or negative 2. And you'll see that my point I do have right here is at negative 5, negative 2. I could do the same thing with x equals negative 3. I'm going to get the same result. X equals negative 3 would be negative 3 times negative 3 plus 4 to the 4th power plus 1. Inside those parentheses, that equals positive 1. Positive 1 to the 4th power is positive 1. So we've got negative 3 times 1, negative 3 plus 1, also negative 2. And if I wanted a couple more points outside of that, I would do the same thing. Now, these are going to be clearly off the graph that I've given, but let's say I did x equals negative 2, moving to the right. One more step. Negative 3 times negative 2 plus 4 to the 4th power plus 1. That's negative 3 times 2 to the 4th power plus 1, or negative 3 times 16 plus 1. That equals negative 47. So that's going to be way off the graph at the bottom. I can just make a quick sketch here, something like that. All right, that's just a quick review of several of the ideas from graphing functions. Horizontal and vertical translations. The horizontal translations inside the function, the vertical translations added or subtracted outside the function. In front of the function, the factor is either a stretch or a shrink, and it may tell you whether the graph is reflected over the x-axis or not. All right, that's it for this one. I will see you in the next video where we talk about behavior at zeros.